I think this is a space that has a lot of potential for growth and impact because the technologies exist to completely transform industrial fossil fuel use. I'm Nick Sawe. I'm a senior policy analyst at Energy Innovation, and I'm really excited about the climate tech map. I grew up with a brittle bone disability where I was stuck inside the house with constant broken bones. And so being out in nature and able to walk was always a sign of being healthy and in the world. And that made me want to really protect those natural spaces and work in environmental science. With industrial heat in particular, I think this is a space that has a lot of potential for growth and impact because the technologies exist to completely transform industrial fossil fuel use. It's about scaling appropriately and giving the tools and incentives to ensure that this technological transition can occur smoothly and successfully. The industrial sector is responsible for about a third of global CO2 emissions, and industrial emissions have also grown 70% since 2000. Providing heat for industrial processes accounts for an overwhelming majority of the sector's fossil fuel use outside of chemical feedstocks. 84%. So creating that heat without fossil fuels is crucial. The heartening thing is that we do know how to accomplish this. Industrial heat pumps, for instance, currently operate at temperatures that cover about a third of that demand. While industrial heat pumps can be over 4 times as efficient as gas combustion alternatives and emissions-free when they're powered with clean energy, there are practical deployment challenges that mean they presently supply only about 5% of industry's heat demand. And the technologies that can supply higher temperature heat to some of the highest emitting industries like steel, cement, and chemicals are also underdeployed, mainly because they're not as commercially ready. These are industries where the capex for constructing a new facility can be north of $1 billion and the equipment will last for decades. So it makes sense that we innovate and lock in clean technologies now. So for higher temperature industrial processes, there are a range of electrified heating technologies, from induction and electric resistance to electric arc furnaces that can produce clean steel. Among the most promising emerging developments are thermal batteries. They can store electricity as heat for up to several days in inexpensive materials like refractory bricks, and they provide that heat back whenever a facility needs it. While the commercially available models top out at temperatures around 500 Celsius, there are upcoming ones that can reach temperatures as high as 1700 Celsius, which covers about 3/4 of the US industrial energy demand outside of feedstocks. Energy storage technologies enable industries to arbitrage across time, only drawing and storing electricity when renewables are at their most abundant and costs are at their lowest. Buying only the cheapest electricity lowers industries' electricity bills while providing stable energy for the industries that are running 24/7, whether they're using their own captive renewable sources or drawing power from the grid. The storage can also provide flexibility services for the grid, helping utilities sell excess electricity that would otherwise be curtailed, and thus reducing costs for other customers. There are also emerging electric technologies that eliminate the need for heat altogether. For instance, electrolysis is widely used in aluminum smelting, but is being explored for clean steel and other applications. Ideally, we'd like to see industrial heat pumps that can output higher temperature heat. Even the best ones under development cap out around 200 Celsius, and more commonly available versions cap out at about half that. Heat pumps also become less efficient as they provide a higher temperature lift, so it'd be great to improve their efficiencies at higher temperatures. Similarly, we should work to commercialize the higher temperature thermal battery solutions that can reach 1700 Celsius. There are also some innovative applications of existing high temperature heating technologies in new contexts. For example, instead of fossil fuels, a Swedish company successfully used a plasma torch to heat a cement kiln. Plasma torches are often used for cutting and welding metal, but haven't commonly been adapted to the cement industry. Adapting these technologies to new contexts will get us off of fossil fuels that are the trickiest to phase out. In terms of alternate sources of heat, small modular nuclear reactors may be able to deliver reliable, high-temperature heat to a nearby industrial facility. These would need to be located near the manufacturing facility. Another local source of heat could be from enhanced geothermal systems. There's been a lot of recent advancement with using drilling techniques from the oil and gas industry to instead access previously inaccessible geothermal resources. Another thing that we need to think about is efficiency and the circular economy. We can conserve industrial energy if we use fewer primary materials and less energy to make our products. Efficiency can happen at the very start of the supply chain with techniques for high-efficiency mining or cleverly designing products to require less material. We can also lean into remanufacturing. This is the practice of restoring and reselling end-of-life equipment, and the US has spearheaded it in industries like auto parts, aerospace, and heavy-duty machinery. But it still only accounts for a very small fraction of our GDP. The remanufacturing industry, if properly scaled, can redirect high-value products from our landfills while driving down costs and improving our supply chain security. I would say keep an eye towards pragmatism in terms of where you put your efforts. So, what are the climate change solutions that meet the political appetite and the economic conditions in a given region or sector that you're aiming to work in? And what are the opportunity windows now, and what areas are likely to present themselves in a few years? How do you build your own knowledge and connections so that you can act quickly when a new opportunity presents itself? I would also advocate focusing strongly on communication skills. Making a tight, compelling case with a call to action, whether you're working on strengthening decarbonization legislation or pitching a new technology to climate VCs or investors, or talking to policymakers to change minds and suggest solutions, all of these and more are part of that diverse communication skill set that really comes up again and again when you're working in the climate and energy space. For those who want to get into industrial heat specifically, it may make most sense to focus on specific technology streams. So thermal batteries, electric arc furnaces, industrial heat pumps, and so forth, and get more involved in the production and adoption and scaling efforts in a given specialization. It's astonishing how undersupported and underexplored solutions are for decarbonizing the industrial sector. Even though it accounts for about a third of the CO2 emissions, it receives just 1.4% of international climate finance. Yet there's a range of actionable and mature technological solutions for transforming it with just a little political or economic support. So that makes clean industry a really exciting space to have an outsized impact on climate change.